Okay, perfect. Then, good afternoon again. Well, as Ernestina has already said to you, today we are going to present the second assignment that you have to prepare for the course. Okay, as you know, we will have no exam, so all the evaluation will be based on the two assignments and their presentations that you have. Okay. Also, for the first assignment, as Ernestina has also said, you will have to present it next week. Okay, next Thursday. Thursday, right? Today's Thursday. Yeah, I don't know in which day I live. Okay. Yes. You will have to present it next Thursday. Okay. And about this assignment, first of all, I want to discuss with you the more convenient dates for you for the assignment, okay? Because as you are only four, I think that the best is for you to choose when you want to present the second assignment and when you want to deliver it, okay? So I have thought that as we have no exam and maybe you have many assignments now. Is that correct? Do you have many assignments now these days in December?
Yes, we have.
Yeah.
Okay.
Yes.
So we have considered then that maybe you can present the assignment and also deliver it after Christmas. What do you think? Is that okay?
It will be great. Thank you so much. I think it's good if other are happy with this.
Yeah.
Yeah, I think that's really good. Yeah.
Yeah. Okay. Perfect. Well, not exactly these days because actually they were days from other assignment that I copied this one. But we can choose, for instance, maybe instead of the 5th, maybe it's better. Okay, let me open the calendar. Okay, I'll show you the calendar here. Okay. So maybe instead of the 5th, maybe you can deliver the first assignment by the 8th. What do you think? Sorry, the second assignment for the 8th January.
It would be good. Yes.
Yes, and present it next week. Okay, so let me modify it here. Well, I like midnight. Okay, you have to prepare the assignment in groups of two people. The first one you have also done it in groups of two, right?
Yes.
Yes.
Okay, so in the same groups, okay. And well, this is not true. We don't have actually class after Christmas, but let's see the best day for the presentation for you. Well, I think that this is your examination calendar, or do you have examination of any course? Because here it is included.
For example,
Which one? Sorry.
on the Thursday, the 14th, we have machine learning.
On the, I couldn't hear correctly. Sorry.
But we won't have an exam. No.
Oh, you don't have any
Yes,
exam.
I think we won't have any exam except the cloud computing because they didn't told us anything about the final exam, but I think the rest is
Okay.
just the final project.
Okay. So for me, okay, let me check because we have, of course, we also teach this course and we have exam for this course. So in this time slot, it is not possible. But in any other time slot, or even in the morning, if you prefer, for us is okay. Well, let me also check my calendar, of course, to say it's Okay, so it's here. I don't know, maybe, well, do you have an exam of this course or not? Because this course belongs to your semester, right?
Yeah, we don't have an exam for that course.
Okay, but maybe well, it's better not to overlap with this. Maybe it's better to do it in the same time slot that we have. What do you think on Thursday, 14th?
Yes,
Yes.
because also we don't have statistical data analysis. Maybe both these days are good for the presentation.
Okay. Then Thursday 14th at 3. Is it okay?
For
Yeah,
me,
that's fine.
Okay. Anyway, if you have other presentations of other courses or whatever, let me know and we can change the day. Okay.
okay.
We
Thank
can
you.
be flexible with that. So let me change it here. We set that on Thursday 14th. Okay, perfect. Now this is clear. Well, we still have to think about this, okay? So don't consider it to be a fixed amount in these percentages. We still have to think. We didn't have time, but when I upload the argument to Moodle, because you will have it there, it will be clear here, okay?
Yes, but sorry, I didn't get the 70% of the scores of the memory. I didn't get it.
No, no,
It's our first.
I will change them, but you have to present.
Okay.
Not well. Here instead of memory, it will be a report. Okay.
Okay.
And, okay. 70. Well, I still have to change the assessment, but
So
we will evaluate the report that you have to deliver, the code, and the presentation.
okay, I get it. But and the third bullet, you said that any file regarding your modeling work,
Here.
can we just use the, for example, Google Colab Notebook?
Well, this is more related to code. Actually, I was not sure if I should keep this. Well, this is more related to the deployment, actually the deployed model, okay? Let me change actually because mm, okay, yes, I think that this is enough for clarification. Well, let me start by the beginning, okay? So the assignment details. You have to develop a cognitive system. You are going to be provided with a data set. I'll give it to you. And you have to perform all the typical steps in a CRISP-DM methodology. Okay. You have to perform the descriptive analysis, data exploration, data preparation, model learning, model evaluation, and deployment. Okay. After doing it, what you are asked to deliver with the assignment is a technical report. Okay, in this technical report, you have to include the scope of the project that you are developing. It's not in the same kind of report that you are preparing for the first assignment, which is a project plan, but you have to deliver more in a technical way. Okay, you have to describe everything that you have done over your dataset in Python or in R or with Weka or any tool that you are using. Okay, it will be a technical report. So you have to describe the scope, and then how have you performed the descriptive analysis? How have you performed the data exploration? Any kind of data preparation techniques that you have also used? Model learning, of course, try to learn several models. Okay, just saying that okay, we are going to learn a decision tree is not enough. Okay, you have to learn several models, compare them, and also you have to give appropriate justification of why you are using those models are not other models. Okay, and of course evaluate your model, and be careful. Evaluating the model is not just saying the accuracy is this. No, okay, you have to say, okay, as we are in this scenario, the best metric to evaluate our model is this one. Also, you may consider the cost, which is you will not have cost, but you can assign a cost to its kind of error or whatever, and evaluate your model in terms of costs and so on. Okay, and finally, you have to describe also the deployment and the use of the system. You are also asked to submit a short video with a demonstration of the use of the deployed system. Okay, not the deployment itself, but a demonstration of the use of the application after performing the deployment. Okay. I was going to say something. Okay, if you cannot, because I think that you can only upload up to 20 megabytes to Moodle, but in that case, maybe you can include, well, you can upload it to Dropbox or Google Drive or OneDrive or something like that, and include a link to the video, okay? But be careful. We are not asking for a 10 minutes video. With 2 minutes, something like 2 minutes, it's okay, okay? Then also, code that you have prepared in Python, R, or the language that you want. Okay, it's up to you. We are not going to say a specific language. Also, the files for the deployment. Okay, if the deployment, if we can test the deployment, include also an URL. Okay, and in that case, we don't need the files. Okay, if you deploy it in a cloud system or whatever, just sharing the link is enough. We don't need all the files for the deployment. And a README document where you explain everything. You can include the URLs here or whatever, okay? You have to prepare a zip file with all the files and upload it to Moodle, okay? By January the 8th, as we said. And you will have to present it. Okay, I will reassign this because maybe we will also assign some scoring to the video, okay? So any question about this? This is what you have to deliver.
Yes, I have a question.
Yes.
First of us, you will give us the data set, yeah?
I will give you the data set.
So it's a data set, and it's based on the what you taught us in a previous course session and today. Yes, it's about time series.
No. It's a classification problem.
So
Okay.
it's not about time series.
No. No, as I said, the time series was just like a seminar inside the course. Okay, no, not going to be evaluated. Okay, we are just going to ask you to prepare a model for a binary classification problem. Okay, we are not teaching you how to do this because you are actually taught to the details about the classification algorithms and so on. You are supposed to have learned them in other courses, okay, of the master.
Yeah.
Here we are going to focus on if you are evaluating the models correctly, if you are performing a good data exploration, preparation, and so on. Okay. We are not asking for the details of the algorithms, but of course you must know those details to justify why you are using some algorithms and not others. Okay. So the problem definition. Here it says, imagine that you are in a hospital, okay, in the health analytics department in a hospital, and you want to improve the results of the diagnosis related to colonoscopies. Okay. For this, as colonoscopies are recorded in video, we want to highlight certain areas of those videos, and more specifically, we want to highlight areas in each video frame, okay, that might be considered more relevant for diagnosing a colorectal illness, okay? And we consider that maybe some areas are more relevant because of the texture of the image or whatever, okay? So we want to analyze videos about colonoscopies. Okay, to achieve this, you already have some information that has been extracted from the videos, so you will not have to cope with that problem. You will have a data set. It's a data set which comes from video sequences, but you don't have to worry about the video sequences themselves. Okay, so in this data set, its sample belongs to a 64 by 64 pixel block. Okay, its line in the dataset, its sample, its instance belongs to a 64 by 64 pixel block. And you have also 26 features for each block. I will describe you the features later, okay? And of course, besides the 26 features, you also have the class labels, which are this block is an important block or it is not an important block. 1 or 0. Okay, 1 is important, 0 is not important. That is the problem that you have to solve. Okay, based on these 26 features, you have to classify a block to be important or not for the colonoscopy. The dataset is composed of 16,000 samples, 16,000 different blocks. Okay, and okay, this is the same that I have said. You are asked to classify a block as relevant or not relevant. Well, as we are going to evaluate your analysis capacities, you are also asked to identify the most important variables that influence in the block for being relevant or not. Okay, the most relevant features for the model or for the models, and here, as well as any other useful information from the analysis of the dataset. Okay, anything that you consider that you have to highlight, also you have to include it in the report. Okay, and you also have the variables here. Okay, anything that you want to ask about the problem that you have to solve? No?
Honestly, I have no idea right now about how I should do that, but I should check the dataset.
Okay. Let me show the features that you have. Okay. Well, I have not said that. Sorry. The information has been extracted from the encoded video stream. Okay. So you have some domain compressed domain features. I will explain to you them. Okay. First of all, you have the quality, which is a measure of the quality of the recorded video. Because maybe imagine if the video is not recorded with very high quality, maybe you have to look at every point in the image carefully because we cannot know that a block is relevant or not, and therefore you have to look to watch at every block carefully. Bits, which is the number of bits used to encode that block. Okay, when we are working with compressed videos, the number of bits of each block might be variable. So we also have this. Now, for these variables, I have to say to you that when we have a video encoded in blocks, okay, each block can be further split or not. Okay, imagine that we have. Let me draw it to you. Okay, this is a 64 by 64 block, with each of these blocks, remember that represents a sample in our dataset, okay? And this block can be split in 4 subblocks, like this, or not. And each of these blocks can, at the same time, be split or not. Okay, maybe this, this, and this, okay? So, and each of these subblocks may reference another frame or only the current frame. Okay, so these variables intraparts are the number of subblocks that do not make reference to other frames. Okay, skip parts is the number of subblocks that are directly copied from other frames. 16 by 16 parts, inter 16 by 16 parts, are the number of blocks with a size of 16 by 16 pixels. So imagine if this is 64, this is 32, and this is 16. So here we have 1 and 2 blocks of size 16 by 16. Okay. Then also number of blocks of with a size of 4 by 4. Here we don't have blocks of 4 by 4. 4 by 4 would be something like this, okay? Which is the smallest possible size. Here we would have 4 then. Okay? And number of subblocks with other sizes. Okay, I don't know if this part is clear or not. You don't actually need to perfectly know what is the meaning of the variables, but more or less to have an idea. Should I further explain or not?
Okay, as I get, could you please just bring the previous page one more time?
The previous page, this
Yes,
one?
yes.
Yes.
Here it says that we have encoded streaming blocks of 64 let's multiply 64.
Mm-hmm.
And the question is that all the video, all those frames
Mm-hmm.
are came into the one image, yeah? That image is 64 pixel 64, yes?
Well, actually, the images in a video, imagine, does not need to be 64 by 64, but because, okay, imagine this is a frame, okay?
Yeah.
And the frame is then split into 64 by 64 blocks.
Each
Okay.
frame.
Each frame. And
So how many frames we have? The BTS, yes?
sorry, how many frames?
And how many frames these videos have?
It doesn't matter for us because actually the samples of our datasets are each of these blocks. Okay. It doesn't matter the number of frames. All you have to do is to classify each block as relevant or not. You don't have to consider the whole video stream.
Just
Only
the block?
sorry?
Just the block?
Yeah,
And
just it's. Let me show the data set. Okay. So this is the data set that you are going to have. Okay.
and each of them is a block.
It's what?
Each of these records are a block?
Yes, of course. Each record is a block. And you only need to focus in a block environment or a block basis. Okay, you can omit that you are working with a video which is composed of frames and each frame is composed of blocks. You only need to know that you will have blocks and you need to classify a block as relevant or not relevant.
It's the binary classifier. We have a records. All of them are numeric, and we should just, for example, use PCA for find the important features and
Yes.
just
Yes.
this. Yeah.
Yeah, of course. Okay, you can go to an abstraction level in which you can omit that you are working with a video and so on. Okay.
And being the video and being the frame is not any more important for us. We just deal
No.
with these numeric records.
Yeah, exactly. Okay. All the other things are to set to you in the problem that you are working with. Okay. So that you may know that these are data which come from a video and so on. Yes,
Good.
I'm recording the session. Okay, I will also upload the session to YouTube. Okay, but of course you can abstract yourselves of this being a video. You only need to know that each record belongs to a 64 by 64 pixel block, and you have to classify each of these blocks as being relevant or not. Okay, it's a simple classification problem. I wanted to explain you everything just to be in the context and for you to know the meaning of the features and so on, okay? But you can abstract yourselves about this being a video. Okay? Is it more clear now?
Right now, yes, thank you so much.
Yeah, no problem. So, have you understood the meaning of these variables according to this? Well, we can omit this, okay? This block represents a 64 by 64 block, so it will be like a record, And you have to know that in the video stream, it can be further split or not. In like this, using a quad tree, which is called a quad tree. Okay. So these refer mostly to the number of partitions or subblocks of each size. Well, this makes reference to the number of subblocks that do not make reference to other frames. Okay, that's enough. Okay, they are intra-frame encoding blocks. They don't need information from other frames. Skip means that the subblock is directly copied from other frames, so the number of straightforward copied blocks from other frame, maybe they can be this one and this one. So this will be 2 for this one. Okay. Number of 16 by 16 parts or subblocks. Okay, in this case 1 and 2, and 4 by 4. We have this 4 here, and other sizes. Okay, other sizes are this, all of these, and all of this. Not being 16 by 16 nor 4 by 4. Clear? More or less. I don't need to for you to have a perfect knowledge about this. Okay, but just for you to know more or less the meaning of the variables. More or less. Clear? Okay.
Yes.
Okay. Okay, number of non-zero pixels. Okay, because after we encode the video, the video encoding is based on the fact that you will have many zeros, and therefore, instead of saying I have to encode a 0, a 0, a 0, a 0, a 0, a 0, it is based on that you will have, okay, I have to encode now 15 zeros, and that's much easier, okay, to encode. So there will be many zeros. The easier the texture is, the greater number of zeros that we will have. So a greater number of zeros will imply that the texture is more uniform, and maybe the block might be marked as not relevant. Okay, so it might be a relevant feature. The frame width and the frame height, the dimensions of the frame. Movement level, without giving more details, is a measure of the level of the movement of this frame respect to the previous one. Okay, how much movement is there in the frame? Okay, for instance, here, imagine that you are recording my screen or my video stream here. This will be a very low level of movement, okay, because there are no many objects moving in the scene. But if you are looking if you are watching an action film, the action film will have a very high level of movement. Okay. Min is the mean of all the pixels in the encoded block. This means here we have 4 submins, which corresponds to the mean of this subblock, this subblock, this subblock, and this subblock. Okay. Then the variance of all of the 4 previous values. Sobel. Sobel is an artificial vision algorithm for extracting the borders in a, well, not the borders, the how you say the, let me, the edges. Sorry, I didn't get the word. Okay, so it's an algorithm to get the edges in an image. So The Sobel operator might indicate that we are working with an edgy block, and maybe an edgy block with edges. Okay, a block with edges is relevant to be considered in the colonoscopy. Variance is the same as the mean, but instead of calculating the mean of the pixels, then we calculate the variance. The level of movement of not about the whole frame, but about the current block in horizontal and in vertical, and also the variation, the variance of the block, of the movement of the block in horizontal and vertical. And then two costs. The cost represent a measure of the cost of encoding this block without partitioning it, and without considering any movement, just copying. Okay, it's like a cost of how costly this is to encode in the data stream. Okay, and finally relevant, which is the target variable that indicates whether the current block is relevant, 1 or not, 0. Okay, any question about the features that you have? Okay, as I said, it's not you don't have to know a perfect knowledge about the meaning of them. Okay, more or less. Anything that you want to ask?
No.
No? Well, actually, as I said, okay, this is just for you to know, because you have to perform that stage of data understanding, and you have to get to the point of knowing with which kind of data we are working and so on. Okay, but it's just information. What you actually have to do is, with this database, to perform all the steps in a ChrisDM methodology that you have learned. Okay. So that's the assignment. Okay. Anything that you want to ask? If you see the data set, well, all the features are numerical features. Okay, you don't have text at all. So in that sense, it is easier for you, I think. Moreover, well, it is not a perfect data set. You will still have to do some pre-processing to it. Okay, because if you examine it, you will find out some things that might be relevant. I will not going to say, at least in the beginning, but you will have to do some pre-processing. Anything that you want to ask? No? Okay, so I'll upload everything to Moodle. Okay, so you will be able to download the assignment as well as the dataset. As I said, you have 16,000 samples in the dataset. It's a significant size for the size of the dataset. And I don't know if you want any other clarification from my side.
For sure, maybe it's most like all of us don't have a very important question right now, but as we go to the project, we will have too many questions, and maybe we should send you an email or just having a Q&A session to solve some of the questions, because right now we just know what should we do and what are the features. But
Yes.
I'm sure from my side, I will have too many questions as I started the project.
Yes, sure. You can email me, or you can also write me here on Teams, because I'm on Teams almost all the day. I also have it in my phone, so I will reply as soon as possible. And if you want to have a meeting here on Teams, we can also have a meeting, of course, no problem. Okay. So I'll stop the recording of the video because I think that it's enough for the YouTube video for explaining the assignment.